Alright, so now we're going to look at problem 1.03. Again, you'll probably have this reminder until we're used to it. The software randomizes the numbers, so the numbers I am using or your classmates are using might not be the same for your problem, but the technique and the type of problem is the same. That's what we're going to focus on. So problem 1.03, part A, is reversing what we did in 102. We're going from scientific notation to decimal notation. So part A is going to ask us, sorry, it's my calendar yelling at me there. It's going to ask us to take the number, in my case, 8.49 times 10 to the fourth. We need to write this as a decimal. Now, 10 to the fourth is a large number. It's 10,000. So we're looking at 8.49 times 10,000. And so, wow, that's 84,900, right? Oh, well, how do we mechanically do that? So you could write 8.49 times 10,000 and work it back out. But what we can do is we can look at the decimal place. So I have a small number I need to get bigger because this is positive, so it's a larger number. And that's what scientific notation is showing for us. It's showing how large the number is. So I'll add some extra zeros here on the right, and I'll move my decimal place 1, 2, 3, 4. So it's going to end up there. So I read that 84900. Now, visually, that's a lot of information for our eyes, so we tend to have a standard of every 3, putting a comma. And so we get 84,900. This tells us that's 10,000 times this number. But we can do it mechanically by moving our decimal place over 4 to the right. So notice this is kind of reversed from what we were doing in problem 1.02. If we moved our decimal place to the left, it generated a positive exponent. Well, here we have the positive exponent, so we have to reverse what we did, and that's why we go to the right. I tend to, left and right rules tend to get stuck in my head. I'm not sure if it's like a geometric dyslexia or whatnot, so I tend to look at this part here and go, is it bigger or smaller than 0? And this number is bigger than 0, so I know I'm going to be pulling my decimal place this way. And I look at this as an actual multiplication problem. But I do it in my head a bit to figure out the direction. And then I let the decimal places come through. So for part B for me, it had 9.7 times 10 to the third. So I'm going to write my 9.7 out. I'm going to add some extra zeros. Again, this is positive, so I'm going to move this to the right. 1, 2, 3. So when I rewrite this, I get 9700. But visually, we like to see commas so that we know, oh, it's 9,700. All right, for part C, well, it looks like I changed my pen color there inadvertently, but we'll roll with it. I'm a flexible person, and I'll pull this up top, part C. It's asking me to write 7.8 times 10 to the negative first as a decimal number. Well, now we have a negative, so we're going the other way. This is a smaller than 0 number, or smaller than 1 number. So I write my 7.8 out, and I'm going to move my decimal to the left. And so I get 0.78. Now, if you've noticed with the Mastering Physics software, some people has, it likes that 0 in front. Traditionally, this is the same as 0.78. I think it's good habit to write the 0 because this can be hard to see. but this is not wrong. But the software, for some reason, does not like it. So just try to keep that in mind. These are the things we learn to be flexible with. So for part D, I have 4.86 times 10 to the second power. So I write my 4.86. Now I'll add just a 0 because I know I'm going to move 1, 2 to the right, positive, so I should get a big number. And so I write that as 486. And then the last one I have here, part E. Move some things around here. There we go. I don't know, that color was a bit depressing. Let's get happy yellow here for part E. Yeah, that's better. Not as dark and dismal. So for part E, I have 3.42 times 10 to the negative fifth. So what does that equal? Well, negative numbers should be small, really small. And this is a large negative number, so it should be a really small number. So I'm going to write my 3.42 here. And I'm going to add some zeros in front of it. I don't know how many I need yet, so I'll do at least 6, I guess. Probably only need 5, but it'll all work out. We'll take our method. So I want to move 5 to the left. 1, 2, 3, 4, 5. And so my number is 0. How many do I have here? 1, 2, 3, 4. 1, 2, 3, 4. And then I write the rest of the number. And there I've converted that exponential or scientific notation to decimal numbers. And so the power tells us which way to move the decimal point, and that helps us translate between